everyone, welcome to today's lesson. We are going to kind of go back a few days and go back to graphing systems of equations. Remember, systems are two or more lines. And we're going to add in now the solving for y part. Okay, so when we do that, we might run into a few different kinds of solutions. So sometimes the two lines might cross once. Sorry, I circled the wrong thing. And that would be one solution. Sometimes they might not cross at all, so that would be no solutions. And sometimes they might cross infinitely many times, so that would be infinitely many solutions. Okay, so let's look at what these three types of problems actually look like. Okay, so for example one, I'm going to start by graphing the first equation here. So again, your last number is your starting point, so I'm going to start at 3. I have -5/3 as my slope. Negative means down, but I always go right. So I'm going to go down 1, 2, 3, 4, 5, right 1, 2, 3. Now I can't get any other points on this line, so I'm just going to go ahead and draw the line through those 2 points. And here is where I'm talking about where we are combining the solving for y portion of last week's lesson. So if I want to get y by itself, I can only graph it, remember, if it looks like y equals mx plus b. Well, right now there's a 3 with that y. So to get rid of that 3, I have to divide, and remember I divide everything by 3. So my equation is y equals, and this is where it's really important to write that 1 by your x up there, so I know that this is a slope of 1/3. And then I'm going to simplify the -9/3 to make it -3 as my y-intercept. All right, I'm going to graph this one here in blue. I'm going to start at -3 this time. And my slope is 1/3, so that means up 1 and right, always to the right. Up 1, right 3. Oh, that was only 2. Right 3. Or I could go down 1 and left 3. And make sure you draw on the lines, else you'll miss points on your test. And we have found now where the 2 lines cross, which is right here at this point. And remember, you have to be careful when naming your point because we always want the x comma y. So on our x, here's our x-axis, we had to go right 3, so that would have been +3. And then our y, we had to go down 2, so -2. So our solution here is 3, -2. Okay, so when I'm looking at the 2 equations, the ones that are solved for y, I'm looking at 2 things. I'm looking at the slope. So I'm going to use my highlighter here. I'm going to highlight the slope. So -5/3 and 1/3. They are obviously different. Okay, I'm also going to look at my y-intercepts here, which is 3 and then -3. Again, they're both 3, but one's positive and negative, so they are also different. So when it asks down here what is the same, well, nothing is the same. What is different? Technically everything, but they have different slopes and they have different y-intercepts. So everything is different. When that happens, we have one solution. And we call these, a lot of times we'll say that the lines are intersecting. So when the lines are intersecting, we end up with just one solution, and that one solution is 3, -2. Okay, so let's look at another one since we've done ones like that before. All right, so I'm going to start by graphing the first one. Now, a lot of people have forgotten how to graph this one. Remember, it's not special because I have 2 variables. Anytime I have both a y and an x, not special. So that means it has a starting point. Well, if there's nothing there, that means our starting point is 0. And 3 is our slope, which means, I'm going to write it out to the side again, it's always rise or fall, and then always to the right. So rise 3, run 1. Rise 3, 1, 1. I'm going to go opposite now. So down 3, left, down and left. Remember, try to get as many points as possible on that line so you can see where they cross. All right, on the second one, I'm trying to get y by itself because it's not by itself yet. So I'm going to get rid of that +3 with a -3. And don't put those together and say 0x or 0. Remember, you keep your x term, and then you keep your constant, the one without the x second. All right, so I'm going to graph this one in pink here. We're going to start at -3. So I'm going to go down 3. And my slope is 3/1. So again, rise and run to the right. So up 3, right 1. And we're going to do that as many times as we can. Okay, so there's our second line. Now remember, our solution is where these lines cross. Well, if these lines continue in that pattern of up 3, right 1, they will never cross. And so where is the solution, or how many solutions do they have? Well, since it will never cross, we are not going to have any solutions. So we say our answer is no solution. And if you remember, we could use the shortcut method or the symbol, which looks like that. Okay, now no solution only occurs when something is the same. It only occurs when the slopes are the same. And the reason being is that these lines have to be going in the same direction. Slopes, that's what slope is. Slope tells you the direction that the line is going. So if the lines are going or have the same slope, they're going to be going the same direction. Okay, but they can't have the same starting point. So they have to have different y-intercepts. And we refer to these lines as parallel lines. But be careful, parallel is not our answer. Our answer is where they cross, and they never cross, so our answer here is no solution. All right, last type of question here. Okay, I'm going to go ahead and graph the first one, which is y = 1/3 x - 2. Again, I'm going to start by going down 2. I'm going to use my slope of rise and run to the right. So up 1, right 3, up 1, right 3. And again, I'm going to go the other direction, down 1, left 3, down and left. There is my first graph. All right, the second one takes a little bit longer to solve this one for y. I have my happy couple here. I'm going to get rid of my outsider, so I'm going to get rid of that +6 with a -6. And I have 3y equals, again, I can't put those together, but so we don't get confused, I'm going to put a 1 in front of the x. So I write my x term first, then my constant. And last, I'm going to divide everything by my coefficient and divide by that 3. All right, so that will give me in the end y equals 1/3 x. And I'm going to simplify that to -2. Okay, so we're going to start at -2. I'm going to go, again, rise over run. So up 1, right 3, up 1, right 3. Huh, that's unusual. If you notice, the two lines, once I solved for y, were exactly the same. They had the same slope, and they had the same y-intercept. What is different? Absolutely nothing. We call these, this is very big vocabulary here, but we call these the same line. I know that's a tough one for you guys. When this happens, remember we are looking for where the lines cross. Well, where do the lines cross? They cross everywhere. They cross here and here and here and here and here and here. And because they have arrows at the end of these lines, they will cross everywhere on that line from then on. So we say that this line has infinitely many solutions, or the system, sorry, has infinitely many solutions. And unlike equations, where every single number you could think of was a solution, this is just every single point on the line. If I gave you the point 0, 0 and asked, is that a solution? The answer is no. It has to be a point on the line. So it's not every single answer, but the list of answers does go on forever and ever. Okay, so that was it for the lesson. Hopefully this was helpful, and we hope to see you guys soon. Bye.